Estimation of P examples. In the first example, suppose we take a random sample of 500 area residents and find that 315 used online tax software last year. Estimate the proportion of all area residents who used online tax software last year using 98% confidence. First, think about the calculations, the formula, the values you would plug into the formula, and what those results are. The sample proportion P hat is the number who used online tax software divided by the number in the sample, or 315 divided by 500. That gives you 0.63 with 4 zeros, or just 0.63. Next, the z-score is 2.326. This comes from the table where we look for 98% confidence and find the z-value. Then we have our formula. In this case, the sample proportion plus or minus the z-score times the estimated standard deviation. So 0.63 plus or minus 2.326 times the square root of 0.63 times 0.37, which is 1 minus 0.63, divided by 500. In this case, I'm going to keep 4 digits after the decimal point for the proportion. So I end up with 0.5798 for the lower limit and 0.6802 for the upper limit. Next, I want to summarize my findings. Now remember, this will contain 3 major components: the level of confidence I'm using, what it was I was trying to estimate, and the lower limit and upper limit that I believe contain that parameter value. I am 98% confident that the proportion of all area residents who used online tax software last year is between 0.5798 and 0.6802. Or, if I convert to percentages first, I might say I am 98% confident that 57.98% to 68.02% of all area residents used online tax software last year. Let's look at another example. In example 2, suppose a random sample of 300 students reveals that 58 have had to skip a meal in the last month because of a lack of funds to purchase food. Estimate the proportion of all students who have had to skip a meal in the last month because of a lack of funds to purchase food. Use 90% confidence. Give the results as a percent rounded to the tenth digit, so the proportion would actually be rounded to 3 digits after the decimal point. We'll begin with your calculations. The sample proportion P hat would be the number who skipped a meal over the number in the sample. That is 58 over 300, which is 0.193333 if we round off to 6 digits. In these exercises, if you have to round off, try to keep at least 6 digits when working with proportions. The z-score is 1.645 because I want 90% confidence. Then the formula, I'm going to plug my values in. So P hat was 0.193333 plus or minus the z-score, 1.645 times the square root of that P hat value, 0.193333, times 1 minus that, or 0.806667, divided by the sample size of 300. Calculate that out, and you should get 0.156 for the lower limit and 0.231 for the upper limit. Next, we want to summarize our findings. So remember, the summary consists of how confident you are in what you're estimating, what is it that you're estimating, and then the bounds within which you think your estimate lies. So I am 90% confident that the proportion of all students who have had to skip a meal in the last month because of a lack of funds to purchase food is between 0.156 and 0.231 as a proportion, or as a percent rounded to the tenths digit. I might say I am 90% confident that 15.6% to 23.1% of all students have had to skip a meal in the last month because of a lack of funds to purchase food. So these are two examples of confidence intervals to estimate an unknown population proportion.